Assalamualaikum and hello everyone. I'm Nur Amalia Aisyah binti Ahmad Nizam, and today I want to introduce to you the topic permutation and combination. So what are permutations and combinations? Permutations is a method used to determine number of ways to arrange items. Remember that in permutation, order is matter. As for combination, it is a number of ways to select item, and remember that in combination, order does not matter. As for example, we have the letter A, B, C. How many ways we can arrange it? We can also arrange it as A, C, B, and as I show you guys here. So, we have 6 permutations, but all of these are considered as one in combinations because they are all letters A, B, C, just that they are arranged in different ways. First, let's see the cases in permutations. There are 3 cases. Case number 1 is when we have n items and we want to arrange all the n items and all the items are different. Number of ways to arrange this is given by n factorial. As for example, suppose we have 4 letters A, B, C, and D. The questions will be determine the number of ways to arrange these letters. So, n will be 4. We want to arrange all the 4 letters and all the letters are different. The number of ways to arrange is 4 factorial, which is equals to 24. It doesn't matter how the questions will be, such as arranging the letters in the word mouse, arranging 3 types of books such as novel, textbook, and magazines. As long as it is all different, then we will be using case number 1, which is n factorial. Case number 2 is when we have n items and we want to arrange only some of the items. Let's say R. Case number 2 is divided by 2 cases. Case number 2A is when we take the items and we put it back, which we call taking with replacement, and the number of ways to arrange this is given by n to the power of r. The questions will be asking you to determine the number of ways to arrange 3 letters from the word friend, and each letter can be used more than once. There are 6 letters in the word friend, so n is equal to 6. We want to arrange 3 letters from the 6 letters, so R is equal to 3. The questions ask that we can use more than once, which means we can take 1 letter and put it back. So, the number of ways to arrange it is 6 to the power of 3, and we will get 260. Case number 2B is when we take the item and don't put it back, which we call taking without replacement. And number of ways to arrange this is given by NPR. As for example, here we have the word friend and we want to arrange 4 letters out of the word. Each letter cannot be used more than once, which means we will take without replacement. There are 6 letters in the word friend, so n is equal to 6. We want to arrange 4 letters from the 6 letters, so r is equal to 4. So number of ways to arrange the letters is 6p4, which equals to 360. There will also some questions be asking about position, such as president, vice president, and etc. This type of question is also non-repeated, or we will be taking without replacement, because one person can only be appointed to one position. Lastly is case number 3, which we have n items and we want to arrange all the items, but some of the items are alike. Number of ways to arrange this is given by n factorial divided by n1 factorial times 2n factorial times until nk factorial. For example, determine number of ways to arrange the letters from the word refrigerator. There are 12 letters in this word, which makes n equals to 12. We want to arrange all the 12 letters. Some of the letters are alike or same. There are 2 E's and 4 R's. So, number of ways to arrange the letters are as shown. Next, I will be talking about combination. As I said earlier, combination is a number of ways to select items and order doesn't matter. No matter how many times you arrange ABC, you will always have a single combination. The only time you will have a different combination is when you decide to choose some odd combination out of the total. Maybe you want to choose R out of n, where n is the total number. So, number of ways to select R items from N items is given by NCR. Like we have here, A, B, C, and N is equal to 3, where R could ever be 1 or 2 or 3. So if R is equal to N, you will always have a single combination. Because here we have 3 items, and we are choosing the whole 3. But what if you decide to choose 2 out of 3? Suppose we have the letter A, B, and C, and we want to choose 2 out of 3 letters. We can have AB, AC, BA, BC, CA, and CB. If in permutations, we will have 6 permutations in choosing 2 out of 3. But we only have 3 combinations here because remember, order doesn't matter in combination. So, AB and BA are the same thing in combination. So, let us apply this as an example where N is equal to 3 and our R is equal to 2. So, for combinations, we have N choose R is equal to N factorial divided by N minus R factorial, then also multiply by R factorial. We are going to substitute from these formulas to see whether we are going to get 3. So, this is the answers. This is just an introduction to permutation and combinations. Next, let's see some problems that are related to real-life situations.
Hi and Assalamualaikum there. I'm Nur Anis Athirah binti Redzuan. My student ID is 2022750683. We'll present to you the example of permutation in our real life. Are you guys ready for it? Let's start. For the first example of permutation in our real life is there are 8 participants in a field. In how many ways the first, second, and third prizes will be awarded? Is this the example of the arrangement? Absolutely yes. This example is about the permutation the first place. Therefore, the numbers of ways will be 8 times 7 times 6 and equal is the 336, or we can use the formula is NPR, where N stand for total number of object and R stand for number of object taking at a time. It means there are 336 ways at that first, second, and third prizes can be awarded.
How should permutation be calculated for this problem using a calculator? First, you need to turn on the calculator. After that, put the N value, which is 8. And then press Shift and multiply symbol, and it will display the letter B, which is considered as permutation. Lastly, put the R value, which is 3. Then we get the answer 336.
For second example of permutation, let's say that you have 6 invitation of your friend in your birthday party, but we have the problem. The problem is we need to solve is how many ways you can arrange for them to sit at a circle table. Here the solution is 6 factorial times 5 times 4 times 3 times 2 and times 1 that equal to 720 possible arrangement for 6 people to sit in a circle of a chair in line. Moreover, in a circle table, we have to take account for those who have repeated the arrangement. So from that, you need to take 720 divided by 6 and you will get 120. It means there are 120 ways for your 6 member can be arranged to sit at a circle table, so that your all 6 member have 120 arrangement for them to sit on their own chair. That's all from me. Thank you.
The last problem for permutation. The situation where Amin wants to know how many lesson plates can be formed. That a card lesson plate consists of 3 different letters and followed by 4 digits, where the first digit cannot be 0. Determine the numbers of lesson plates that can be formed. So, to illustrate this problem, we can draw a box like this to make it easy for us to solve this problem. For these 3 boxes, we need to put a different letter. We know that the alphabet has 26 letters, which is A until Z. So N equal to 26. There are 26 letters that need to put in 3 slots. This means that we want to arrange 3 letters from 26 letters. So R equal to 3. The letter can only be used on, so we need to use this formula, which is NPR. Therefore, the number of ways equal to 26P3. Next, for the rest of the box, we need to put some digit or number. In this case, said that the first digit cannot be 0, so we can only put numbers from 1 until 9. They are 9 digits, so N equal to 9. They are 9 digits that need to put in one slot. That means we want to arrange 1 digit from the 9 digits, so R equal to 1. We also use this formula, which is NPR. Therefore, number of ways equal to 9P1. After that, the last 3 boxes, we need to put some digits. But for this, we can include 0. So, we can put numbers from 0 until 9. They are 10 digits, so N equal to 10. They are 10 digits that need to put in 3 slots. This means that we want to arrange 3 digits from 10 digits, so R equal to 3. You should note that if the question does not mention the number of times the digit can be used, then we just need to assume that the digit can only be used once. The number of ways is equal to 10P3. Therefore, the number of lesson plates that can be formed is 26P3 times 9P1 times 10P3 equal to 101,088,000 ways. Next, let's take a look at some problems for combination. Problem 1. It said that for mathematics club activities, teachers need 5 students to be selected from a group consisting of 9 guys and 6 girls to participate in a contest held by the school. Determine numbers of ways to make the selection if among the 5 students there must be at least 4 girls. Now, it said that among the 5 students that we want to select, there must be at least 4 girls. This means that we can select 4 girls or 5 girls. If there are 4 girls, then there will be 1 guy. And if there are 5 girls, then there will be 0 guy. And numbers of ways to select 1 guy from 9 guys is 9C1. And numbers of ways to select 4 girls from 6 girls is 6C4. Number of ways to select 0 guy from 9 guys is 9C0. And number of ways to select 5 girls from 6 girls is 6C5. Therefore, number of ways to select 5 students where there are at least 4 girls is 9C1 times 6C4 plus 9C0 times 6C5 equals to 141 ways.
For this combination problem, you just need to press 9 and then press shift and then the divide symbol. So the C capital will appear on your monitor and then you press 1. Repeat the step to find the number of ways in this problem. Just follow the equation and you will get the total ways. The total ways are 141 ways. Next, I will explain the second problem. An athletics club has 10 long distance runners, 8 sprinters and 5 jumpers. A team of 3 long distance runners, 5 sprinters and 2 jumpers is to be selected. Find the number of ways in which the team can be selected. Now, let's look at the information given. 10 runners, 8 sprinters and 5 jumpers. it's better for you to underline the information in the question. The question needs a team of 3 runners, 5 sprinters, and 2 jumpers. So, here we have 3 boxes representing runners, sprinters, and jumpers. So, how do we select the 3 runners from 10 runners? It's going to be represented by combination of 10 taken 3. Now, for the sprinter, we're going to select 5 from the 8 sprinter, and that will be combination of 8 taken 5. And for the jumpers, we need to select 2 jumpers from the 5 jumpers, and that's combination of 5 taken 2. Then, using your scientific calculator, multiply 10 taken C, 8 taken 5, and 5 taken 2. So, it will get 67,200 of teams satisfying this condition. Now is the last problem. The problem states a school committee of 5 people is to be selected from a group of 4 teachers and 7 students. Find the number of different ways the committee can be selected if there must be at least 1 teacher and there must be more students than teacher. When you saw the words committee and selected, so that means this is a combination problem. I am advise you guys to underline all the information that you can see in the problem. So, from the problems, we need to select 5 people from 4 teachers and 7 students. Okay, so now, let's list 4 teachers and 1 student. It's meaning there are 4 teachers and 1 student, so the total is 5 people. Next, 3 teachers and 2 students. Also, the total is 5 people. 2 teachers and 3 students. Also, total 5 people. 1 teachers and 4 students. And the lastly is 5 students and 0 teacher. Also possible to be correct. Now, let's try to satisfy the condition. There are actually 2 conditions. The first one is there must be more students than the teachers. So, which among the list is satisfy this condition? Eliminate 4 teachers and 1 students because there is less students than teachers. Same goes to 3 teachers and 2 students. The another condition is at least 1 teacher. That means 0 teacher and 5 students must be eliminated because there is no teacher in that committee. So, this one is not satisfying this condition. Next, we calculate the combination. Selecting 2 teachers from 4 teachers, there is combination 4 taken 2. To selecting 3 students from 7, there is combination 7 taken 3. Multiply these 2 combination, we will get 210. Next, for the second case, the second possibility is selecting 1 teachers from 4 teachers, combination of 4 taken 1, and then we have 4 students from 7, combination of 7 taken 4. Multiply these 2 combination using calculator, we will get 140. Don't forget to add this all out, and that will give you the total is 350.
Assalamualaikum warahmatullahi wabarakatuh. First, let me introduce myself. My name is Siti Noraisah binti Mohamad Sidik and my ID number is 2022736629. Firstly, before I give a conclusion about this topic, I just want to say that mostly people think that math can be considered by some to be slow, boring and unsurprising, meanwhile others see it as a sophisticated word of pattern art. Math can be utilized to find solutions to a variety of issues in our real life. Many people are unaware of how to apply it in a practical situations. When you consider things in the actual world, permutation and combination are constantly at work. Permutation are merely an alternative mathematical lens through which to view the world. We may distinguish between the two by looking at the various notation that involves permutation and combination. We can obtain a group of data in the form of sets and subsets with the use of the permutation and combination. Another definition is a various way of arranging particular categories of facts. When there are various types of objects and things, permutation is applied where the order of the data is matters. Combination refers to the smaller grouping that can be created from a larger group considered where the order of data doesn't matter. Permutation are needed to organize a sequence of items, while combinations are required to determine how many different groups can be made. The proof concepts are very important in mathematics and very useful in our daily life. Besides, two of the most fundamental concepts in probability are permutation and combinations. They are essential for students to understand since they are particularly useful in statistics as well as in other branches of mathematics and in a daily life. As an example for permutation in real-life problem, we can look at the problem number 1. We can see in problem number 1 that has shown in various member group, we can use a permutation in order to find how many possible ways that top 3 rankings can be determined. For example, 2 and 3 is involving on how to encourage people to sit at the table and the number of lesson plates can be formed. We use permutation formula in these 3 situations so that we can get the result without have to calculate it by manually. It will be difficult if we have to write the possible outcome and count one by one. Can you imagine if we had to count it to hundreds, thousands or even millions? It will take a lot of time and energy to do it. So we can simplify it by using the permutation formula. Okay, next, we look at the problem that involves combination in real life. In problem 1, 2 and 3 that have been stated earlier, we can see that it's also involving on selecting people, same with the permutations. But in every equation, it has been stated that conditional that we need to follow when we want to make a team or groups. So this is a difference between the permutation and combinations, which is the order of the data. In combination, the order of the data is a method in order to find the ways different with the permutations, which is the order doesn't matter. We can use the combination formula in this situation to get the answer. So by looking at these few examples, we can realize that permutation and combination is actually important in order to help us in our daily life. Permutation and combination are highly useful in many different aspects because they offer workaround and other options for solving issues. There are several uses for this technique in relation to people, animals, plants, traffic system and so on. This method application could appear straightforward at the first, but after through research, they produce significant outcome. In the end, we can conclude that understanding combination and permutation is important in order to understand the world around us because they enable us to make a better decisions without ignoring any potential outcome.